who Nutanix is, what we try to solve, or where we try to help you. And actually, I will zoom in quite a lot on the details on our storage service that we provide up to the virtualization layer. But before I go into my slide deck, I would like to thanks the entire vBrownback team to organize this. It's great to have this opportunity to talk to you. And if you have some questions, my details are on the screen. Just feel free to reach out. So, who is Nutanix? Nutanix is a company raised in 2009. We launched our first product in 2011. And since 2011, we already won several Best of VMworld awards in the last 3 years. The first one was the Best of VMworld award for VDI, or end-user computing, 2012 for big data, and 2013. So this year we won the award for the Best of private cloud solution. And actually that says a lot of what types of virtualization workloads you can run on Nutanix. I always like to say that you can run all your virtual machines, or every virtual machine belongs up onto a Nutanix platform. So we're in Europe now. We have a nice European coverage. We have more than 150 partners, lots of customers, and we are with more than 15 employees here at Nutanix. So what is the Nutanix solution? What we did is we combined several infrastructure layers or resources into one virtual computing platform. So we combined the compute resources and the storage resources in order to run your virtual machines more efficient. And actually what we commoditized the entire virtual infrastructure. So here's another overview. We at Nutanix, we're a software company, but we package our software into a hardware layer. So what we did is we use commodity off-the-shelf x86 hardware. On top of that, we have the hypervisor installed, and on top of the hypervisor, we have our virtual storage controller. And within that virtual storage controller, we have bundled lots of IP, so intellectual property, to really commoditize that underlying infrastructure, so you can have a building block to run all your virtual machines or all your virtual applications. Now, lots of people always think that Nutanix is a storage company. I always disagree with that. We are not a storage company. We provide you a platform to run all your virtualized workloads, and storage is just one of the data center services that we commoditize through software. We also have a huge control fabric. So to manage that platform, we have a very state-of-the-art GUI, also based on REST API, so you can script and you can automate all stuff running on Nutanix. Now, this session will handle all this. We'll handle the details of the storage service that we provide. And before I take a deep dive, I would like to take a minute to ask you, what do you want or what do you expect from the storage services in your data center? Most of the times you want data integrity. You want your data be available up to your virtualization stack all the time. You want to manage it very easily. You want to have decent performance, and you want the solution to be as cost effective as possible. Now, if you look these days to your storage architecture, you will see that most of the times you will not hit those requirements. And just one example of that is the storage management. If you take a look at how many steps you need to take to run your virtual machines on new storage, you will see that you will have in this slide, for example, 6 steps in order to bring up your volumes, to rescan your ESX host, and then start to deploy your virtual machines. Now, wouldn't it be great that you can eliminate lots of these steps by software? And that's what we try to do at Nutanix. Now, not only at Nutanix, we try to help you with that, but if you look at, for example, Google, at Facebook, at Microsoft, if you go to their data centers, you will see that they do not have any types of centralized storage. They are really using commodity hardware that they pick off the shelf with a software layer on top of that, and then distribute or actually run all the data center services on a software layer. Another thing is that if you look at the architecture at those types of data centers, is that it is a really scale-out solution and not a scale-up solution. These days, when you go have a look in your data center, you will see that on the server side, most of the times you have like blades or blades, for example, it's like a scale-out architecture. But on the underlying, the storage architecture is always a scale-up architecture with 2 or 4 storage controllers, and that's it. That's not a scale-out solution. So what we did at Nutanix, with the principles that we learned from big data projects, we created a distributed system with Flash for a very, very great performance. We created a distributed architecture specially built for virtualization, and you can focus, as the VMware administrator, you can focus really on those services provided by VMware, and you do not have to manage that infrastructure layer anymore. Now, we always receive lots of questions on how we handle the IOs, how we optimize the storage. So in the upcoming slides, I will talk about three things. I will talk about data availability and how the software handles node failures or hard disk failures or whatever type of failure. I will talk about data localization and how we make sure that the virtual machine data is always as close as possible to the virtual machine itself. And I will also talk about how we optimize that data fabric. So first, the basics. We have, in this slide, you will see a visual overview of a node. A node is a server with direct attached storage, with a compute, and with a hypervisor. On top of that, we have the virtual storage controller. That controller VM handles all the IOs coming from the user VMs or the production VMs. What we do is, because we have a virtual storage controller on every node, we build actually a distributed file system across all nodes. And every time you add a node into the Nutanix cluster, you will get an additional virtual storage controller. So you can scale out from very linearly. So you can add a node, you have more capacity, and you also have more performance then. The beauty is that these controller VMs, they share the metadata. So the metadata is also shared on a distributed manner across all your nodes. That's a huge, huge advantage when you compare that, for example, with a traditional architecture where you are limited with a certain amount of storage controllers. I already explained that the beauty of Nutanix is that we learned from big data. And if you take a look at the big data applications, all these services are distributed and spanned across several nodes. That's what we did within our file system. So we built a file system based on the same principles as, for example, Facebook did to share and to distribute the metadata in your cluster. Now, how do we write our data to our local disks? We do not use, for example, array technology to protect our data. When we write our data blocks, at the same time we will replicate that data to another node in the cluster to make sure that the data is always available on at least 2 places in that cluster. But on the other hand, when we read the data, we will always read the data from the local nodes. That's why we can have such great performance, because we have that SSD local next to the compute bus, so we can run that virtual machine very, very quickly because we can utilize all the power that SSD will give us. Now let's assume that the data is not available on the local node because, for example, a disk failure or whatever type of failure, because the metadata is distributed across the nodes, we can very easily get that data from another node, and at the same time we will copy that data to the local node, so during the next read operation that data will sit local next to the hypervisor. Now, we also have built-in lots of intelligence in that data fabric. That's how we name it, the data fabric. So we will recognize I/O patterns. We will do different types of I/O management tasks based on what type of I/O is coming in. For example, if you have lots of sequential IOs, it doesn't make any sense to put that data on SSD. So we will move that data straight to the spindles in our nodes. But let's say that after a while that data becomes hot again and lots of users are requesting that data, we will move that data to the hot tier, to the SSD tier. On the other side, when you have lots of random I/O, we will again recognize that I/O pattern and move that data straight to the SSD tier as a persistent write buffer. Of course, we compress our data. This is to make sure that we can store more data on our hard disk and on our SSD drives. Something new that we introduced a few weeks ago is deduplication. So we will now also dedupe the data coming into our flash and into our caching. So it is not dedupe for capacity reasons, it is dedupe for performance reasons. So why do we do that? If you can put more data blocks in your SSD tier or in your cache tier, you can do more with the same hardware. So we ran some tests in a VDI environment, and we saw that when we enabled deduplication on SSD, we noticed that we were able to boot up lots of virtual machines in half of the time than when you compare it without deduplication. So in this stage, deduplication is really introduced for a performance perspective. But in the near future, we will of course also introduce that for capacity reasons on our HDDs. Another huge advantage, not for VDI but for server virt, is that when you dedupe that data in the SSD tiers, we noticed that we improved our data store latencies up to 4 times. So that's a huge win that we now have with the introduction of deduplication. Of course, in our intelligent data fabric, we try to optimize the IOs coming from from VMware, for example. And therefore, we are working closely together with VMware to make sure that we are compatible with, for example, the VMware APIs for View, the VKI, but also device, for example, to offload storage tasks straight to the data store of Nutanix instead of, for example, cloning virtual machines with vSphere resources. Something else that we introduced now is the linked clones optimization, which is a huge win in a VDI environment. If you think about it, when you run with different nodes and when you run your virtual machines on the different nodes within a VDI environment, and if you use a linked clone architecture, lots of your reads will go over the network to your base image. So the performance will maybe not be always as good as you can have when you use a centralized storage, correct? So that's why now we recognize when a disk is a master image in a view environment, and then we will shadow that master image to each node that runs a linked clone machine. So again, that virtual machine will run local on that node, and we will have a huge win with regards to our read performance. Another question that comes up a lot is, okay, how do you work together with, for example, vMotion or DRS or high availability? Of course, these basic VM operations, that's what I call it, they are all supported on Nutanix. So if you want to migrate a certain virtual machine, for example, during a maintenance task or with DRS and you trigger vMotion, the data of that virtual machine will follow the VM. So when that guest VM wants to access, in this case, block A or block B, which is not available on the node, we will go get that data from the other node, and again, we will make sure that the data sits as close as possible to the virtual machine. On the other hand, hardware can fail. That's why VMware has great technology such as high availability. So when you have a node failure, for example, VMware HA will kick in. It will restart that virtual machine on another node in your HA cluster. And again, we at Nutanix, we will make sure that that file system will run as optimized as possible. We will again distribute all the data blocks to make sure that the data is again available on other nodes and that the data is as close as possible to that virtual machine. So again, you do not have to worry about your storage infrastructure. We will handle that. We will actually create one huge resource pool from your storage, and all the intelligence is placed in the software layer on that virtual storage controller. Some possible next steps if you are here at VMworld, make sure to drop by our booth where we can give you lots of demos with regards to end-user computing, with regards to DR, with regards to big data. If you like technical blocks, if you like technical diagrams, make sure to go to Stephen Pointras. His blog, he's one of our solution architects. He created the Nutanix Bible. It's a fantastic resource, so make sure to go after that website. And we are also very active on Twitter and social media, so if you do not follow the Nutanix account yet, make sure to follow that one to receive all the latest product updates and to receive all the news with regards to Nutanix. So again, to finalize, thank you for attending this short introduction of, let's say, 20 minutes of Nutanix. Very, very short zoom in into the storage resource that we provide to you. And also, again, thank you to the V Brownback crew to organize this. And I wish you all a very pleasant day. So thank you all.